I was wrong. I just brought greatness out in my memory.
Problem 26 on the SBAC. Alright, we got a triangle. 5, 12, and what's the other side?
On the SBAC.
SBAC.
Smart balance.
Smarter balance.
I'm a 10th grader.
I know. Preparing you for next year.
Alright. Okay.
You know, my daughter's doing this in 7th grade.
That's insane.
This same practice test.
How is she going to know any of it?
Well, she won't know a lot of it, but like the sine and cosine stuff.
If I took this in 7th grade, I'd just rip it up and walk out of the classroom.
She actually, surprisingly enough, does a lot of it. So, she just has to learn to, like you said, sine and cosine. So with this sine and cosine stuff, what are we going to do here? Well, the first thing I like to do, if I see something like 512, don't we know the other side? It's a Pythagorean triple, right? It's a Pythagorean triple. Look up there on that board. What do you see? Pythagorean triple, 3, 4, 5, right?
Yeah.
5, 12, 13.
Uh-huh.
7, 24, 25.
Yeah.
8, 15, 17.
Correct.
Which one's this?
What are you looking at?
Yeah, I know. I was just agreeing.
I'm so lost there. Where are you?
I feel like you just made that up because it wasn't really up there.
Yeah.
It's been here since last year at the beginning of the year.
I wasn't here.
Oh, this one is a 5, 12, 13.
Yes.
I feel like you
Now-
told us that when you listed all of them off.
Pretty much, yes. So, you could have found this out by a squared plus b squared equals c squared, right?
Yeah.
25 plus 144 is 169. 169 square rooted is 13. Bam, done. Okay. Yay, we found out that 13 is there. Now we need to do the actual problem. And that is, determine if each of these expressions is equivalent to the length of AC. So I need to know what is the length of AC, right? Well, let's think about this. If we're talking about sine, and we're talking about B, right? We're talking about opposite, right?
Yeah.
Over,
Adjacent.
nope, sine, so,
Oh.
opposite
over
hypotenuse, right? So that's opposite over hypotenuse. So that would be 5 over 13, right?
Correct.
So the sine of B would equal opposite, or 5 over 13, right? And if I multiply both sides by 13, then these would cancel and I'd get this 13 times the sine of B is equal to 5. And is 5 AC?
Yes.
It is. So that would work. 18. Okay.
And we have. Never mind, I'm not taking this off.
Well, we still have to.
Wait, hold on. I thought we were taking our midterms this week.
Next week.
Oh, okay.
And this week.
And this week.
No, I'm just kidding.
I was like, what? How does that work?
Next week. And so, what about cosine A? How's that going to work? What is a cosine?
I adjacent over hypotenuse.
I don't think it changes color on me. I'm kind of confused why I can't change color.
We did it. I think there was like an easy pad somewhere that you can pop up on the side of the screen and you can make it change colors.
That's what I thought, but
Because that's how it was at Auburn. Wait, hit that again?
Is it this?
No.
Yes. Wait, where's the ink? So, okay. Oh, turn on Smart Ink.
There you go.
There we go. All right, now we can do it.
Do you have to restart now? 'Cause,
No,
you're
we're still
doing it.
going. We're still doing it. It's all right.
Just different colors.
If they can fast forward if they want. So, if I want to talk about cosine, then I'm going to talk about A. Then let's write this same thing. 13, 5, 12. But this time this is with A, right? And so cosine is adjacent. So adjacent would be this side, right? And so cosine A would be equal to adjacent, or 5 over hypotenuse, which is 13, right?
Yes.
And if we multiply both sides by 13, again, we would get 13 cosine A is equal to 5. And we both agree that 5 is AC, right?
Yeah.
So that would also be a definition, or be equivalent to AC. So that one's good, right? So now let's look at the tangent. Now, one of these you would think would be right, and one of them is going to be wrong, right?
Yes.
So which one?
12 tangent A is yes.
You think 12 tangent A is yes?
Yeah.
All right, let's take a look. So 12 tangent A. So when we talk about tangent of A, we're talking about A.
Opposite.
Okay,
over
so we're talking about
adjacent.
opposite over adjacent.
Yeah.
So the opposite is 12, and the adjacent is 5, right?
Oh wait.
And so tangent, that's good though, you notice.
Yeah.
Tangent is opposite 12 over 5, and the whole time we really wanted 5 on top, right?
Yeah, I did 12 on.
Yeah. So we actually just want the other one,
Yeah.
right? So this one's a no, but the tangent of B should go the other way, meaning the tangent of B.
That's a square.
That's
Or
not
it's a
right.
rectangle.
Yeah.
That's not a triangle.
Thanks for pointing that out. So we had the tangent of B. So that's going this way, right? So that's opposite over adjacent. So that would be
There we go. That one's yes.
that would be 5 over 12,
Yeah.
right? Is which what we want. Tangent of B. So then we multiply by 12, and we get is equal to 5, which is AC. So yes. And that's how we would do that problem.
Tricky, Dan. Tricky.
Not really tricky. She's tricky.